Today we are going to talk about proving that a quadrilateral is a parallelogram. Textbook page number 367 to 374 and workbook page number 154 to 157. So how do you know if a quadrilateral is a parallelogram? If a quadrilateral has each pair of opposite sides parallel, it's a parallelogram by definition. So this is not only test, however, that can be used to determine if a quadrilateral is a parallelogram. Let's check your understanding from the previous lesson. Complete the statement about parallelogram ABCD. Segment AB congruent to what? AD, will it BC or DC? What do you think? Yeah, of course the answer is segment DC. Opposite sides are parallel, right? And they are equal. Check this one. Complete the statement about parallelogram ABCD. AD perpendicular to, AD congruent to what? BC. Now angle D congruent to what? Of course congruent to angle B. Okay. Now this answer will be angle A congruent to angle C and angle B congruent to angle D. So you recognize and applied properties of parallelograms. Now we are going to discuss about recognize the condition that ensure a quadrilateral is a parallelogram. Prove that a set of points forms a parallelogram in the coordinate plane. Let's discuss theorems. Theorem 6.8 states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Look at this. If ABCD is a parallelogram, I mean the quadrilateral, look at this here. If AB congruent to CD, if these two sides are equal, and BC congruent to DA, then we can say ABCD is a parallelogram. Well, let's check Theorem 6.9. Theorem says that if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. Look at this. Measurement of angle A, the next consecutive angle is B. So measurement of angle B equal 180. Same way measurement of angle A plus measurement of angle D equal 180. Then we can say this quadrilateral is a parallelogram. See, if I am considering C, C plus D or C plus B, that is also possible. Well, the next theorem 6.10 states that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Look at this. If angle A congruent to angle C and angle B congruent to angle D, opposite angles are congruent, then ABCD is a parallelogram. Great, now let's check the theorem 6.11. It states that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. That means in this figure, see AE congruent to CE, see, and BE congruent to GE. Then we can say ABCD is a parallelogram. That's all. Now let's check the proof of this theorem. Here, given that AZ and BD bisect each other at E, and ABCD is a parallelogram, that's we need to prove. So let's check how you'll prove it. See, AC and BD bisect each other at E. That's already given. That means you can say AE congruent to CE and BE congruent to DE. Same way you can say angle AEB, this angle congruent to angle CED. We know the property of this angle, right? So let's check it. And angle BAC congruent to angle DEA, this angle. BEC, this angle, and DEA, this angle. We know they are vertical angles, and this is the definition of segment bisector. That's the reason. So from this data you will get triangle AEB congruent to triangle CED by SAS congruency criteria. And here we can say from this two data we can conclude triangle BAC congruent triangle DEA by SAS congruency criteria. So by CPCT, that means corresponding parts of the congruent triangles are congruent, we can conclude angle BAE this angle congruent to angle DCE this angle. Okay, same way you can say angle ECB congruent to angle EAD, same reason CPCT. So we can say AB, the segment AB parallel to segment CD and BC parallel to AD. The reason, if alternate interior angles are congruent, then lines are parallel. So we can conclude ABCD is a parallelogram, because definition of parallelogram, these two sides are opposite sides are parallel, they are equal, we can say they are congruent. This is a parallelogram. Okay, now let's check the theorem 6.12. It states that if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. That means if here BC, the segment BC congruent to DA, that means equal to DA, then these two are parallel, BC parallel to DA, then you can say ABCD is a parallelogram. So from all these you can consolidate. These are the things you have to prove in that a quadrilateral is a parallelogram. Lesson we are discussing prove both pairs of opposite sides are parallel by using the definition of the parallelogram. This will be the diagram. And theorem 6.8, we know prove that both pairs of opposite sides are congruent. 6.9, prove that an angle is supplementary to both of its consecutive angles. And 6.10, prove that both pairs of opposite angles are congruent. And prove that the diagonals bisect each other in theorem 6.11. Finally, theorem 6.12 says prove that one pair of opposite sides is congruent and parallel. These are the topics we are going to apply, the coming topics, coming examples and exercise. Identify parallelograms. Determine whether the quadrilateral is a parallelogram and justify your answer. Look at this, the opposite sides are provided. This is 35 units, this is also 35. Opposite sides are 35 and this is also 20. So each pair of opposite sides has the same measure, therefore they are congruent. So if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So look at this. Here answer will be D. Which method would prove that quadrilateral is a parallelogram? Because one pair of opposite sides both parallel and perpendicular. So in this figure is clear, this is perpendicular, these are parallel, and moreover they are same measurement. So we can say we'll use this idea or this point to prove these two triangles are congruent. This figure is a parallelogram. So the diagram shows a carriage jack used to raise a car from the ground. In the diagram, look at that, AD congruent to BC and AB congruent to DC. Based on this information, which statement will be true regardless of the height of the car jack? Can you say angle A congruent to angle B? Is it? Or angle A congruent to angle C? Or what you think? Side AB congruent to BC? Or measurement of angle A plus measurement of angle C equal to 180? So what will be the answer? The answer should be B. Angle A congruent to angle C. They are opposite angles. Look at example 3. You can also use the condition of parallelogram along with the algebra to find missing values that make a quadrilateral a parallelogram. So the first part of this figure, this question, solve for x and y so that the quadrilateral is a parallelogram. So first we are solving for x. We know the segment AB congruent to segment DC. We know opposite sides of a parallelogram are congruent. And AB congruent to DC, definition of congruent segment. So we can say 4x minus 1 equal 3 times x plus 2. after distribution, we know this will be 3x plus 6. Finally, we can get x equal 7. Now we are going to solve for y. Here AD perpendicular to DC, y AD perpendicular to BC, sorry, AD congruent to BC, because opposite sides of a parallelogram are congruent. So we can say 3 times y plus 1 equal to 4y minus 2. We are distributing, so we can say 3y plus 3 equal 4y minus 4y minus 2, and it will be, we are substituting. At that moment you will get the value y minus 2 equal, here the 2 will go to here to be 5, right? So y equal to 5. So we can say y equal to 5. Now find m, so that the quadrilateral is a parallelogram. See here, this is parallelogram. So how you will find the value of m? 4m plus 2, 3m plus 8. We'll equate it, right? So what will be the value of m? Yeah, it will be 6. So let's conclude. What are the topics we learn here? We prove that both pairs of opposite sides are parallel, and prove that both pairs of opposite sides are congruent, and an angle is supplementary to both of its consecutive angles, and we prove that both pairs of opposite angles are congruent and the diagonals bisect each other. Finally, one pair of opposite sides is congruent and parallel.